Alright, welcome Math 1 students to a video on 8.3 rotations. So picking up where we left off, at the bottom of page 39, so this is a picture of the notes that we took, and at the bottom of page 39 there was the key concept box at the bottom about rotation about a point. So in order to have a rotation you need to have a couple of different things. So let's define a rotation and then look at what we have as part of the rotation. So a rotation of x degrees about a point Q which is called the center of rotation, is a transformation with the following properties. So let's look at what they're talking about. We have a Q, which is the center of rotation. Okay. So that's this point right here. Every rotation needs to be around a point. And the other thing is we have x degrees. So x degrees is this right here. So what the x degrees is telling you is, let's say we have a point V right here, and it is rotating x degrees, and it becomes the image V prime. And if we were to take a segment from Q to V prime and Q to V and measure this angle, that would be x degrees. Okay, and we could do that for all of the points, for W, for U, and it's rotating in that position. So W is going x degrees, U is going x degrees. Those are all the same degrees. All right, so back to the properties. We have that if the image of Q, which is our center of rotation, is itself. So Q doesn't rotate anywhere new. It stays where it is. Kind of like a point on the line of reflection doesn't reflect in any way. Okay, for every other point, you're going to have, so QV right here and QV prime, they're going to be equal. They're going to be congruent. So the distance away from the center of rotation is going to stay constant. Okay, and then X, the name of X, the angle is called the angle of rotation. Obvious name. Okay, so linked on the checklist below the videos are a couple of GeoGebra activities. And so I'm going to go to one and show you a few things. So hold on. Okay, so on this week's checklist, there's a Rotations GeoGebra Link 1 and Rotations GeoGebra Link 2. So first I'm going to show you Link 1. Okay, so this is something that you can actually interact with if you click on that link. And it shows a triangle. This is the pre-image, and another triangle, which is the image. And you can see that this point right here is your center of rotation, and 135 degrees right now is the angle of rotation. So there's a little slider here where you can change that angle of rotation. So here's 180, here's 225 degrees, 270 degrees, 315, and back to 360. So at 0, it doesn't go anywhere. 45 degrees, etc. Now this particular animation is going clockwise. For your book, unless they state otherwise, you're always going to be going counterclockwise, which is this way. Okay, so it's actually, well, not really that way, but it's, well, I'll show you. I'll show you in the next one. Okay, so, and that is something that's stated right here. Unless otherwise stated, rotations in this book are counterclockwise. So counterclockwise means it's going against what a clock does, so it's going in that direction. Clockwise, if you think of a clock, clockwise goes this direction. So that's not the way that we're going to go. We're going to go the opposite direction. Okay. So now I'm going to go to the second link, the second GeoGebra link. and it looks like this. So it's where I just clicked on that other link, it's the number 2. Okay, so what we have here is something similar, but it's going to go counterclockwise, and we're looking at it in the coordinate plane. And that's important because we want to see the patterns in the points. So right now this is at 0 degrees, so what I have is a rotation on top of the original, which is why you see these doubling of the points. It's basically the same triangle on top of itself. So a 0 degree rotation doesn't go anywhere. Okay, so the point that we are going to use as our center of rotation in the coordinate plane is this one. It's the origin, where the x and y axis come together. All right, so just like before, there's a slider, but I'm only going in 90-degree increments. Okay, so first let's go 90 degrees. There we go. Counterclockwise. So you see how it's going this way. We're looking at the angle this way. If we went the other way, that would be 270 degrees. Remember that a full circle is 360 degrees. Okay, so this is 90 degrees. And so these little lines here show you the angle that's being created here. Okay, so let's look at the points that we get. A, which was at the point 2, 1, A prime is now at negative 1, 2. So what exactly is happening? Okay, well, let's look at B. B was at 4, 6. B prime is at negative 6, 4. So we're kind of using the same numbers. It kind of looks like we're switching them, but it's not just switching them. We're also making one of them negative. You can see what was a positive 6 is now a negative 6, which was a positive 1 is now a negative 1. So it looks like we're switching them and then making the what was the y negative. And then let's see, for the C, if we switch them, you get 0, 5. And if we make the 0 negative, it doesn't change it. There's no such thing as a negative 0. So on your second page of your notes that we pasted in on page 41, and I just realized right now that I gave each of you 2 of the same thing. So that was silly, but this is exactly the same thing as this. We only needed one of them. I accidentally copied too many, so you can cut that part off or whatnot. Okay, so here we're looking at a 90-degree rotation about the origin. So let's take a moment to talk about the notation that your book uses. Recall that a capital R was for reflection, and so we don't want to use a capital R. We want to use a lowercase r. So it's a lowercase r, and then there's like parentheses right here, and then you have x degrees, whatever the degrees is, and then you have O. O stands for origin. Okay, so this part is how many degrees are we rotating it? And remember, we're always going counterclockwise, so we don't have to state the direction. And this is the center, which is usually going to be the origin. Like I said, you can use any point, but we're going to simplify it and just work with the origin. So this is your center of rotation, okay? So for our first one, we looked at 90 degrees counterclockwise. So they're taking this point G, 2, 3, and it becomes negative 3, 2. So in general, the point xy is going to become negative yx. So you're switching the x and the y, and the one that was the y is now negative. Okay. So now let's go back to the GeoGebra activity and let's move it to 180 degrees. So if we move it to 180 degrees, we have a different case. The A is now negative 2, negative 1. The B is negative 4, negative 6. And then the C is negative 5, 0. So recall what your original points were. Do you notice what's happening? If you said that the x and the y are staying in the same spot, but are changing signs from positive to negative, or if they were negative, they would change to positive, but they're changing signs. In fact, you can play with this thing. You can move the points. If you opened it up, you can play with this all you want. You can move b. So what if b was a negative number? So it had a negative. So now it has negative 1, 6. So what would happen is if we followed this pattern and changed the signs, it would become a positive 1, negative 6. And that's where it is. It's a positive 1, negative 6. So you'll find that you can't drag this one because it's dependent on this one. But I can put this one anywhere. Maybe I'm going to flip it over and put it here. Okay, so it was 4, negative 3. Now it's negative 4, 3. Isn't that great how math works? Okay, so I forgot what it was. 5, 5, 4, 5. I don't know. We'll leave it there. Okay, so with 180 degrees, all you have to do is change the sign of the x and y, but don't switch them. Okay? So let's look at 270 degrees. So 270 degrees, so you can see this is 270 degrees counterclockwise. But that's actually the exact same thing as 90 degrees clockwise. It would land on the same thing. So let's see what is happening to A. So A was 2, 1. Now it's going to become 1, negative 2. So we're switching them again. The 1 is in a different spot. But this time you'll notice it's not the 1 that's changing to negative, it's the 2 that's changing to negative, or the first one, the x. When it moves, it becomes negative. So here we had 4, 5. It becomes 5, negative 4. 5, 0 switches, and it's a little hard to see, but that's 0, negative 5, right? This is negative 5 right here. And again, feel free to play with the points. All right, we can't play with these ones, but I can play with that one. Or I can move it there. And when I move it, it changes the other ones. So you can create all sorts of fun designs. Woo! And yes, rotating they can overlap, you can see. Okay. This little checkbox here just shows you see how we have the green segments from A to the center of rotation and A prime to the center of rotation? If we click on this, you'll see the other segments created, and it shows you, it kind of gives you a cool little picture of B to the center of rotation, B prime to the center of rotation. You can see they're going to be the same length. So the pink ones, the green ones, and the purple ones here are going to be pairs of congruent segments, because that when you rotate, the distance away from that center has to stay the same. Okay, so looking back at our notes, there we are. Okay, so to summarize what we just looked at, for 180 degrees, xy becomes negative x, negative y. For 270 degrees, about the origin, xy becomes y negative x. So you'll notice there's a slight difference between this one and this one. In this one, the negative goes with the y. In this one, the negative goes with the x. So then the last one says 360 degrees. Wrong color. 360 degrees means a full circle. You can see the full circle here. And when you rotate something a full 360 degrees, it lands right back where it started. So the point is exactly the same. xy is to xy. Okay, thanks for watching.